All right, so our lesson for today is about the change of base rule, but more in general, it's about how to use your calculator to find logarithms that you can't figure out in your head. Because so far we've been doing logarithms where like you can just like logically figure them out. For example, if you do log base 3 of 81, we know that this equals 4 because 3 to the 4th power equals 81. But what we're going to learn how to do today is how to find logs of, like, say, log base 3 of 28 or something like that. Because if you're doing log base 3 of 28, you know that it's got to be bigger than 3 because 3 to the 3rd power equals 27. So if you're trying to find what equals 28, you know it's got to be bigger than 3, but it's going to be some decimal. So what we're looking at today is how to find the logarithms of things that you can't figure out in your head and how to use your calculator for that. So if you look at your calculator, all calculators look a little bit different, but any scientific calculator should have a log button and a natural log button. So on this one, it looks like this. So log is just log and natural log is ln. So everybody look at your calculator and make sure you can find those two buttons. Okay, so I think we might have mentioned this a little bit last class, but if you ever have a log where it doesn't say what the base is, it means that it's base 10. So if you were asked to calculate log of, say, 9 or something like that, what that really means is that you're finding log base 10 of 9. And the reason why it's like kind of, I guess, abbreviated like that, or like you just don't write the 10, is because our number system is based on 10. You know, like you have your tens column, your hundreds, your thousands, and like our whole number system is based on 10. So this is one of the most common logs that we calculate. So go ahead and practice calculating this in your calculator. And what would log base 10 of 9 be? Okay, awesome. So you get this decimal 0.954, etc. And what this means is that if you do 10 raised to the 0.954 ... that should equal 9. And if you want to, you can go ahead and try that out. Type in 10 raised to a power of 0.954, etc. And if you only type in 0.954, you might get like 8 point something, but it should be close to 9. Is that what you guys thought? Okay, so this button will always calculate log base 10 of whatever you put into your calculator. And then the natural log button is like if you're asked to find the natural log of, say, the 5, what this is calculating is log base E of 5, where E is Euler's number. So we talked a little bit about this, I think, like 2 lessons ago. But Euler's number is an irrational number. It's like 2.7159, something like that. But it's a decimal that goes on infinitely long, just like pi does. And that number shows up a lot in exponential functions because it's used to model compounds. It's used to model population growth, all sorts of things like that. And so natural log basically means you're finding log base E. So everybody go ahead and practice using your calculator. What is the natural log of 5? Okay, awesome. And what this means is that E raised to the 1.609, etc., that this equals 5, which seems reasonable, right? Because E is like 2.7-ish. And if you do 2.7 to the 1st power, you're going to get like that 2.7. If you do 2.7 squared, you're going to get some number. Actually, I don't know what that would be, but it's going to be like 6 or 7 or something like that. And so it makes sense that a decimal in between those would give you the number 5. Any questions about these two calculator operations? Okay, so on your homework, you guys are going to have a bunch of questions that are super easy because you're literally just practicing using your calculator. So like if you type in log of 10,000, what does that give you? 4. And this is one we could have done in our head, right? Because log of 10,000, if there isn't a base, that means that it's 10. It has a base of 10. And so it's saying that 10 to the fourth power equals 10,000. And that's something we could have figured out in our head, but your calculator will also give you that same answer. So you'll have some questions like this. Some of them you'll be calculating the log. Some of them you'll be calculating the natural log, but you're literally just typing it in your calculator. Yeah.
I don't know how to do it, but my calculator, when I press log, will only let me do 10.
So are you typing in log and then the number?
Yes.
Or so some scientific calculators, it depends on your calculator. Sometimes you click the log button and then you type in the number you want to take the log of. Other ones you have to type the number in and then click the log button. So like if you want to do log of 7,000, my guess, you probably have to type in 7,000 and then say.
It's like log of 381 equals 4. It won't let me change the.
Yes, yes. So we're going to talk about what you do in that case, because that's absolutely right. Yeah, so your calculator will only do log base 10 and natural log. Those are unless you have some really special calculator, these two logs are the only types of logs you can calculate. So on question 12, I think, on this one, we're asked to find log base 8 of 480. So what that's asking is 8 to what power equals 480? Well, this isn't something we can do in our head because this isn't going to be a whole number exponent. You know, we could approximate it, say like, I don't know what 8 cubed is. Someone want to calculate that real quick? 512. Okay, so we know it's going to be a little bit less than 3, but it's also going to be bigger than 2. So it's going to be some decimal, like 2 point something. But we don't know what that is because it's not a whole number. And our calculator also won't calculate that because we don't have a log base 8 button. We only have log base 10 and log base E. And so this is where we use the change of base rule. So the change of base rule says that you can take the log of any base of a number and you can change the base. And if you change the base, this logarithm will be equal to this fraction. And you can change this to any base. So you could choose to have C be 5 or 12 or a million or whatever you want it to be. However, it's usually smart to choose it to either be 10 or E because those are the ones that your calculator can calculate. So what we would do if we want to calculate that question that we had up before is log base 8 of 480, I think. So if we want to calculate that, we're going to use the change of base rule to change it to logarithms that our calculator can calculate. So we'll change this to log base 10 of 480 divided by log base 10 of 8. And when we calculate that out, go ahead and put in your calculator, what's log base 10 of 480? That's close enough. And then log base 10 of 8. Okay, awesome. And we can just like check to see if these are reasonable, you know, for these individual logarithm calculations. Is it reasonable that 10 raised to a number that's slightly bigger than 2 but less than 3 equals 480? Yeah, because 10 squared would be 100, 10 cubed would be 1,000, 480 is between 100 and 1,000. Same thing here, if I do 10 to a decimal that's less than 1, it makes sense that it could equal 8. Okay, but the change of base rule, it's not either one of these numbers, it's these two numbers divided by each other. So when you divide those two, what does that give you?
So I just put mine already in fractions and the log 480 and then log 8 on the bottom, and I gave you the answer 2.968.
Okay.
But I don't know if that's what everyone else is gonna get divided.
That sounds right to me, because I think that's the same number my last class got. Is that what you guys got as well when you divided these? Yeah. 969. Okay, that's probably just a rounding error then. Yeah. Perfect. Yeah. And I think on your homework, it will say like be precise up to 4 decimal places. So you will want to write out probably more decimals than this in order to make it precise up to 4 decimal places. Okay, perfect. Awesome. Yeah, but it will be somewhere in this range. And if we think about this, let's think about what this means. It means 8 raised to this exponent will equal 480. Well, that's reasonable because remember how we predicted it's going to be in between 2 and 3? Well, this number is between 2 and 3. Now, we could have done this calculation in a different way. So we chose the base 10, but the change of base rule applies for any base. You could choose it to be base 15 or a million or whatever you want it to be. But we chose 10 because our calculator does log base 10. But what's another logarithm that our calculator also does? Natural log, which is log base e. And so I could have also calculated log base 8 of 480 as being the natural log or log base e of 480 divided by the natural log of 8. So what's the natural log of 480? Okay, what's the natural log of 8? Okay, and if you divide those two numbers, what does that give you? The same number? Yep, and that's what you should get. Because the change of base rule works regardless of what base you choose. So the individual logarithms might be different. Well, the natural log of 480 is different than the regular log of 480, which makes sense because this one is saying e to this exponent equals 480 versus this one saying 10 to this exponent equals 480. And it makes sense that this exponent has to be bigger because e is like 0.7. And if you do 2.7 raised to an exponent, you're going to need a bigger exponent to get to 480 than if you do 10 raised to that exponent. So these numbers will be different than these two. But when you divide the two numbers and you find the ratio is the same in either case. So when you're doing a change of base rule or you're trying to use a calculator to figure out a logarithm like this, it doesn't matter which one you choose. You can choose to do a natural log or you can do just like a regular log base 10. So you can choose whichever one you happen to like the most. All right. So you'll have some questions like that where you'll need to find the logarithm of some other number. You'll also have some questions that will utilize the stuff that we learned last class. So for example, let's do like this one. So on this one, we're asked to find e raised to the exponent of, or we're asked to simplify this. We can't actually find it because x is an unknown number, but we're asked to simplify this. Well, the natural log, what's the base of the natural log? 2.7, or we could also just call it e because that's the name of that number. And so what this looks like is we have e raised to log base e of 7x. Well, according to this property that we learned last class, if you have any number raised to log of with a base of that same number, those essentially cancel each other out and you just get this number. And so in this case, if we have e raised to log base e, that's just going to equal the argument, which is 7x. So we can use these same properties that we talked about last class to simplify them. And I've added the change of base rule here because technically the change of base rule is a property. So we now have 8 properties. 7 of them we learned last time and 8 we learned this time. Any questions about that? Okay, and we can also use this to simplify more complicated expressions. Like for example, where was that one I wanted to do? Oh, I think I put it at the top so I'd remember it, but now I can't remember where it's at. Okay, this one. So in this case, we're finding the natural log of this formula, which this is a finance formula, where P is the initial principal you invest in something. This is the interest rate, and this is how long you invest the money for. So if we want to find the natural log of this, let's look at the structures that are showing up in this. So we've got two things multiplied, so we will probably end up using property 5 because we've got P and E to the RT are being multiplied. And then we've also got the exponent where you've got E to the RT. So to simplify this, this exponent, does it just apply to the E or does it apply to both of them? Okay, I heard I heard both answers. So in this case, it actually just applies to the E. If they wanted you to apply it to both, they would have put parentheses around the P and the E. Because order of operations says you always do exponents first. So if they wanted you to multiply these together first, they would have put parentheses around them. So since this exponent only applies to E, we're not going to use the exponent rule yet. We're going to first separate out the multiplication. So our multiplication rule says that if you take the log of things that are multiplied, you can separate those out into the log of each thing separately added together. So I'm going to write this as the natural log of P plus the natural log of E to the RT. And when you type this into your homework, I think your homework system is kind of finicky and you have to put the parentheses. A lot of the times when you're just like writing out the math, like I don't usually write out the parentheses, but on your homework, they do need to have the parentheses so they know what you're taking the natural log of. Okay, so this is partially simplified, but can we simplify it further? Yeah. Which property should I use to simplify it? Yep, I can use 7 because that's my property that allows me to simplify exponents. So in this case, I have R times T as my exponent. So I can bring that out, and this is going to be the natural log of P plus R times T times the natural log of E. Now, can we simplify this any further? If so, how would I simplify it? Okay. What's the base of the natural log? And if you do if you do log base E of E, it just equals 1 by property 2. And so I can actually simplify this to be the natural log of P plus R times T times 1, which will just be R times T. And so this is a fully simplified version of that. Any questions on that? Okay. So the main thing, like kind of one of the main key points of this lesson is that natural logs have base E, regular logs have base 10 unless it says otherwise. So you'll have some problems like that. You might also end up with a question like this one. If we were looking at this one, which property do you guys think we could use to simplify it? Okay. Yeah, so 6 involves division, and we could think about this as division, right? Because we could think about it as log of 1.5 raised to the T plus 4 divided by 10,000, I think, right? Like that's the same thing. So we could use the division rule, which says that we do the log of the top. So we'll have log of 1.5 to the T plus 4 minus the log of the bottom. So that give us log of 10,000. Everybody good with that? That's what property 6. Okay, what other properties could we use to simplify this? Yep, we could use 7 to simplify our exponent. And our exponent is T plus 4. So I'm going to put parentheses around there to show that I'm doing T plus 4 times log of 1.5. And then can this be simplified at all? What does this equal? 4, right? Because this is saying 10 to what power equals 10,000? Well, 10 to the fourth power equals this. And even if you didn't like know how to do that in your head, you could also just type it in your calculator and your calculator would tell you that's 4. So that gives us a -4. And then if you wanted to get an approximation, you could also type this in your calculator and get that decimal. And you could distribute that decimal to the T and to the 4. And then like when I can't remember what this is. I think it's like some really small decimal, like 0.2 something. But you'd get like 0.2 whatever T, and then 0.2 times the 4. That would give you some small decimal, and you could combine the like terms with the -4. So you can do it that way, or you could just type it into your homework like this, because this would be fully accurate versus if you calculated this, you'd get an approximation because this number is infinitely long. You know, like you've got this infinitely long decimal. And so like if you were to plug this in your calculator and use that number, it's going to be an approximation. And I think your homework will accept it either way, depending on which way you do it. Any questions on that? Okay, cool. I also want to point out on this one, with the multiplication and division rules, they're very, very similar to each other. And depending on the way you look at the problem, you could use either one. Because you could have also solved this problem by saying I have 1/10,000 times this, and you would have had the log of this plus the log of this. But go ahead and type in your calculator, what's the log of 1/10,000? -4. And notice that we still ended up with a -4 because that log of 1/10,000 is saying you do 10 to the -4 power to get this number. So the -4 will show up regardless of whether you use the division rule, where you have minus log of 10,000, or if you do log of 1/10,000, which gives you a -4. It'll give you the same answer either way. Okay, the last question I want to go over is question 14. So this is another practical application of logs. We talked about like how you can measure the magnitude of an earthquake with logarithms, like that's one of the things we use. But we also use it to measure pH, which determines like how acidic or alkaline something is. So the definition of pH is that the pH, which is a number that describes how acidic or alkaline something is, equals the opposite of, actually, let me write this out a little bigger or zoom in at least. So pH equals the opposite of log of this number. Now, I took chemistry as like a sophomore in high school, so I don't actually know what this notation means, but based on the word problem, because they ask in part C, what the concentration of hydrogen ions is. So this expression right here is the concentration of hydrogen ions. I don't know exactly how they measure it or anything like that. If you're in chemistry, then you would know. But that number describes the concentration of hydrogen ions in some type of liquid or substance. So on parts A and B, you're asked to find the pH when you're given the concentration of hydrogen ions. So in that case, let's do like maybe part B. The pH of part B is going to be the opposite of log of 1.88 times 10 to the -6. And so basically you just plug that into your calculator and figure out what that is. So I'll open up my calculator. And I'll go to my scientific calculator. And I'm going to type in, this calculator requires the number first. So I'm going to type in 1.88 times 10 raised to 6, that's negative. When I hit enter, that gives me this decimal. That's basically just like the decimal version of this scientific notation. Then I say, okay, I'm going to take the log of that. And according to my pH formula, the pH is the opposite of the log of that. And so in this case, my pH is going to equal positive 5.7 to, 5, etc. Any questions on that? And that's just the definition of what pH is. So whatever, I think we were finding the pH of milk. So if we look at this scale, we found that the pH was 5.725. And so we can see that milk is like right in this range here. Okay, so that's how you would do part A and part B. On part C, you're asked to do the opposite. So you're asked to find the concentration of hydrogen ions in a glass of wine if the pH is this. So they give you the pH and you have to find the hydrogen concentration. So to do that one, the way that you would calculate that is you just plug it into the formula. You say, well, our pH is 4.75. This equals the opposite of the log of this positive hydrogen thing, which I'm just going to call it regular H, but technically this is the notation for it. So we want to figure out what H is. So if we think about how to solve equations, I haven't taught you guys yet how to get rid of logs, but you do need to have the log stuff by itself. So how would we get the log of H by itself? Divide by what? Okay, so this isn't log times H. So I'll teach you in just a second how to get rid of the log, but we have to get the log part by itself right now. And right now we have a negative log. So how do I get rid of the negative? So this is, think about it as -1 times log. So how would we get rid of -1 times the stuff we're trying to get alone? Yeah. Perfect. Yeah, we could either multiply or divide by a negative. In either case, it will cancel out the negative. Okay, so we'll divide both sides by a negative or multiply, and we get -4.75 equals the log of H. I'm going to teach you guys another method to do this in our next class, but the easy way to think about this is log base 10 of H equals this number. How would you write that in exponential form? You guys remember how to? Close. Close, yeah. So what's the base of this? 10. So that's going to be the base of my power. Close. Switch them. Yes. Because remember, logs give us exponents. So the fact that log of whatever H is equals this means that 10 to that power equals H. And so then you just figure out whatever that is. You're going to get some really small decimal. That's the concentration of hydrogen ions. And I'll teach you guys another way to solve logarithm equations tomorrow. Well, Wednesday. But that's how you would calculate that. Any questions on that last part? Okay, awesome. Then I'll let you guys go ahead and get started on your homework. If you have any questions, let me know. And also just remember to finish the practice exam before Thursday, because Thursday is going to be our in-class final exam review. So you'll get more out of it if you try the review before class. So let me know if you have any questions and you can get started on your homework.